Hi everyone, this is our lab 4. This lab is about the instantaneous rate of change, which also called the derivative of a function and the average rate of change. So combining of these two knowledges. So let's look at the first question. The first question says the falling curve is a model of a population, so changes with time. So the first one asks, so over the period from 5 to 7, this derivative changes increasing or decreasing. So if you look at here, this derivative means the slope of the tangent line. So from 5 to 7, the tangent line becomes more and more horizontal. That means decreasing of the derivative, right? So the second one says compare the derivative at 9 and the average rate of change. So at 9, this is almost horizontal, right? This tangent line, and this line is. Give me a second. This line here is the average rate of change. So this line's slope is clearly bigger than the slope at 9, right? So this here we choose less than. So the third question says over this whole period, how will this derivative change? So if you look, take several samples, you will see that this derivative changes like increasingly up to 5, and then changes decreasingly from 5 to 10, right? So first increasing, then decreasing. So that's the first question. The second question asks us to use definition of derivative to calculate the derivatives, right? So let's take the second question, for example. The others will be similar. Okay. So the second question says is 1 minus square root of x plus 5, and take the derivative at 2. So by definition, f derivative at 2 equals this following limit. Take this d goes to 0, f2 plus d minus f2 over d, right? Plug in this function's expression. And simplify, we get root 7 minus root 7 plus d over d. And here we use the trick which multiply by the same number on both numerator and denominator to cancel this square here. So the factor we should use is this one. So square root of 7 plus square root of 7 plus d. 7 plus d. So the numerator gives us 7 minus 7 plus d. Okay, denominator is d, root 7 plus square root of 7 plus d. And the numerator here, as you can see, is actually negative d, right? And since these two d cancel, and we get minus 1, root 7 plus root 7 plus d. Don't forget this limit. So now here we can take the limit, and the limit makes sense, right? So minus 1 over 2 root 7, and that's the answer. And you can check this formula here. This we get from the power rule, right? So this again gives us the same answer. right? So that's the second question. A third question gives us this exponential function. And the first one asks about the average rate of change, and you just calculate by this formula here. That's the average rate of change formula, okay? And so the second one asks how the derivative change, because this is a increasing exponential function. Its derivative will be faster and faster, right? If you draw the graph, the graph is like this. The slope become more and more vertical. That means the instantaneous rate of change is increasing, right? Okay. Then question 4. Question 4 asks us to use power sum and constant multiply rules to calculate derivatives. So let's look at the first one. So the first one, to use the power rules, we write it as 1/3 x to the power -1 plus 5 times x to the power -0.4. And like the power rule says, x to the power constant c is derivative is c times x to the power c minus 1. We make use of this rule here, so we get the derivative of h. The first part, right, the constant term is just the coefficient we just copy, and here x to the order -1, we use this formula, so c is -1, right? And x to the power -1, so -2. And we get this part. And the second part is similar, right? Basically applying this formula. And the second one, f equals absolute value x plus 1 over root x. Because this 1 over root x is defined only for x positive, that means this domain for fx is only for the positive numbers. So that means this absolute value is actually equals x, right, for positive numbers. So fx is actually equals x plus 1 over square root of x. And you rewrite it is x plus x to the power -1/2. And the first part, you use the derivative, you get 1. The second one, you take the derivative, again using this power rule, and we can get this answer here. Okay. Okay, the last question. The last question gives us this function here, and asks us to get the tangent line for x at 2. So when x equals 2, f2 equals 2 plus 1/2, so 5 over 2, right? So, and then we can also calculate the derivative. The derivative at 2 is, by this calculation, is 3/4. So then the line at x equals 2, we can assume its equation is y equals 3/4 x plus a constant b. And how to calculate this constant b here? Because this line goes through the point at 2, 5, half here. So you just plug in this data into this line, you get this 3/2 plus b equals 5/2. This means b equals 1, right? You take this equation and you solve for b. And then you get the equation for the line. So that's the last question. Okay, that's it.